Thank you for joining us today, and welcome to Production Modeling Corporation's webinar presentation. Today's topic will cover the critical role of manufacturing simulation in your system's performance. Our presenter today is Ed Williams, Senior Technical Specialist at PMC.
Thank you, Veronica, and welcome everyone. Ed Williams speaking. The company has a good history, lots of clients served, lots of projects completed. If you divide those numbers, you get 10. That's a lot of repeat business on the average. And established 79, but I didn't join until 2002. And I work here as Veronica said, as a senior simulation specialist. Our regional offices around the world allow us to devote 24-hour attention to hot projects. And significantly, we do much more than simulation. Industrial engineering has a whole stable of powerful techniques. And very often, these techniques work much more powerfully in synergy with each other than they do individually. So here's simulation modeling here on the left, but it combines very powerfully and beneficially with many of the other industrial engineering analytical techniques shown on this slide. And there's a pedigree of some of our best known customers among the 700, so there's many others. Now, as the techie, I'm eager to get into the technical part, and we do that here. There are so many decisions to make. This is just a short list. You could fill many more slides with other decisions that engineers and management have to make in today's extremely volatile business climate. And simulation can help with all of these. The great value of simulation is that you can try what would happen if we took a certain decision. You can examine the effects without actually making the decision for the moment. It might be expensive, it might be time-consuming, it might be disruptive to actually put the change in your real-life system. So the idea of simulation is you put it in a computer model built according to your system as it currently stands. What if we changed one or several things? What would happen? And you run the model to find out. And likewise, there are so many objectives. Multiple clients have stressed to us over the 22 years I've worked here, all of these objectives and many more. Equipment is expensive. You'd like to have high utilization. Same with your workers. Queue lengths, it's nice if they're short. It's nice if waiting time in a queue is short. Inventory drains money away, so it's nice to keep it low. But then again, you don't like stockouts. And if you're going to have downtimes at all, and no, we've not figured out a way to eliminate them entirely, it's nice to have them both rare and short. That's an interesting tidbit about data collection. When downtime data is collected to build a model, you need to collect both how often does a machine go down and how long does it take to repair. And there's so many interactions. These arrows go back and forth. All those wonderful, desirable objectives act rather like a teeter-totter. It can be very difficult to realize both at once to the full extent you might want to. There is typically a sweet spot in the middle. An example of that would be inventory levels. placing a new order costs money, so you don't want to do that too often. On the other hand, you'd like to keep your inventory low, but you'd like to keep stockouts very rare. So what should the reorder trigger point be, and what should the reorder quantity be? There's a sweet spot in there, and simulation can help you find it. You'd like your queues to be short and your equipment utilization to be high. Well, exactly how much equipment should you have? Not too much, not too little. There's a sweet spot in there, and simulation can help you find it. And the same is true with many of these other trade-offs. So what's a manager to do? Well, as you saw on a previous slide, simulation is one of the techniques. It's the one we're going to emphasize today. And we have a full arsenal of powerful weapons of analysis to attack our clients' problems and help them toward solutions that go straight to the bottom line. That's a good place for them. And here are some of these methods of attack. Simulation modeling, today's topic, put it first, but simulation modeling absolutely cannot be separated from statistical analysis methods. Any simulation model I've ever built, and I've been building them for 45 years because I built them at Ford before I retired from there and joined PMC. Any simulation model ever built is going to have randomness in it. You can't predict exactly when failures will occur. You can't predict exactly when a supplier will go on strike. You can't predict exactly how long an individual cycle time will take. And therefore, statistical techniques are required at both ends of a simulation to analyze the input data that is going to go into the simulation model and to analyze and interpret with methods like confidence interval building, hypothesis testing. They're the most common. You get into the remaining ones on this list when you have a couple dozen alternatives versus just 2 or 3 alternatives to consider. So expertise is required both in building the simulation model and in preparing its input, analyzing its output, and interpreting the results to go from those numerical output of the computer to specific recommendations to management on what to do next to improve operations. The sensitivity analysis is very easily and accurately done in a simulation model. For example, if I make a small improvement in the cycle time on a machine, I may adjust the machine. I may decide on the basis of a simulation model to purchase a more expensive, newer machine that cycles faster or has shorter and less frequent downtimes. I may decide to invest in worker and operator training, not only to reduce the lengths of operations, but to reduce their variability. That's a key point that comes up statistically. Often reducing variability is at least as valuable as reducing the mean of something, like the average cycle time or the average time to repair a machine or to transfer goods from one part of the factory or the warehouse or the hospital to another. So in simulation, we can study, suppose we were to make a small reduction in a machine's cycle time. And that would cost money if you actually did it. The simulation model might tell you it won't do any good at all because that machine is not currently the bottleneck or the pinch point. It may do you quite a bit of good if that machine is the bottleneck. And you have limited funds that you can invest in process improvement. If we need to achieve a 10% improvement to adjust to increased market demands and customer expectations, where should you put the limited funds you have? A new, faster machine, or this, or this, or this. And an important point is that list can get longer and longer and longer. And it's quick to try all the alternatives. I showed just 5. I've seen as many as 10 or 12 suggestions. A simulation model will not come up with a message on the screen saying machine X needs to run faster. The simulation model will tell you how your system behaves in terms of throughput time, number of parts processed per hour or day or week or shift. It will tell you those numbers. But it's up to management to think of promising ideas that can then be put in the simulation model. Therefore, all of us have the practice of asking our clients a lot of questions and listening very carefully to the answers before building and analyzing a simulation model and presenting any of its results. Another important power of simulation is that if there's a hidden interaction, you may not even know of it yet. Think back to the previous slide. I had a starter list of 5 ideas, and no doubt each of our clients can think of many more that are context-based. It may be that implementing idea A doesn't do much good. It would not be worth the expense and time required to implement that idea. And the same may be true of idea B. However, and this is very quick to check with a simulation model, it may be true that if both ideas are implemented, you'll see a dramatic improvement. That's where the statistical technique of design of experiments is particularly useful. And computer simulation can explore many of those possible synergies to find the good one, the best one, among many alternatives very quickly. That's one of the valuable capabilities of simulation. Now, here are some examples. All of them are ones I've personally been involved with at PMC in the 22 years I've been there. And I've deliberately picked a list for this slide that is extremely wide-ranging to call to attention the broad applicability of simulation. Historically, and this was still true in the 70s and 80s when I worked at Ford, simulation was first and historically and most often applied to manufacturing. Then it branched out to warehousing. Now it's branched out to healthcare, office operations, service industries, transportation networks, and other examples that you can see on this slide. No matter what your industry, there's a highly promising chance that simulation can plump up your bottom line. And as I say, there's many examples here, and we'd be eager to work with you to add more. So I'll open it up now for questions and discussion. Questions will be most welcome. And check the chat box here.
We had a few questions come in for you. And if you, again, to our attendees, if you have any questions, please use that Q&A feature. One we did receive is, if you're new to simulation, how do you pick your first project?
My first and foremost advice, very strongly, I've repeated this many times, keep your first project small. Don't simulate the hospital. Simulate the radiology room. Don't simulate the factory. Simulate the brazing department. Don't simulate the entire transportation, logistics, supply chain network. Simulate the roadhead operations from one particular rail terminal. The model will be quicker to build. You'll get the reassurance of useful results faster. And it will be like psychologically, if simulation is new to you, it will take your time to feel comfortable with it. It's like getting the first olive out of the bottle. Another strong candidate is many of our clients are telling us, with the enormous volatility in business conditions they're seeing, clients have built up some contingency plans. A contingency plan, what will we do if a supplier goes on strike? What will we do if the relative cost of transportation by road versus railroad shifts dramatically? What will we do if a hurricane shuts down one plant just as market demands are increasing? Oh, we have a contingency plan in the drawer. Well, of course, we've never tested it yet. How well would it work? We can build a model of your current operations and then put the concepts of a contingency plan in the model and see how well your contingency plan will work. Does it need modification or improvement before the dark day when it is actually needed? So that's another strong candidate, other than the general recommendation of a small first project to get started with simulation if it's new to your company.
Awesome. Thank you so much, Ed. Another question here. What statistical expertise and software would be available for a simulation study, aside from the simulation software itself?
Yes, first you need the simulation software. We have 10 or 12 at PMC, and we'll pick the best one. The best one can change dramatically depending on the project demands. But in addition to that, I've remarked that statistical work is needed both to prepare the input data for the simulation, and some software needed for that is typically distribution fitting. Find, if it exists, a good mathematical description of input data like cycle times or repair times or transportation transit times. There's specialized software, which we of course have, to do that at the front end of a simulation. At the back end of a simulation, statistical software, and that's different packages, we have those too, for analyzing the output, undertaking the building of confidence intervals, regression analysis, hypothesis tests. In the bigger projects, the design of experiments I mentioned, that statistical software has to be available. We have it. And statistical expertise, as well as model building expertise, is required. Now, those two expertises Depending on project staffing, they might be inside the same person or they might be 2 or 3 different people. But teamwork in both software usage and personnel is very important to a successful simulation project. And as the client, you're part of that team. You aren't just passively waiting for an email with results in it.
Okay. So I don't see any other questions. This is the last one. So if you do have questions, please again use that Q&A feature. What objections typically arise and need rebuttal to get a simulation project started?
The most obvious one, and certainly the most frequent one I've seen over 22 years, is the time, both in money, or the cost, both in dollars and in time required to do the model. One of the best rebuttals is try it once. You can look at the literature, and there's many, many examples of successful simulation projects that readily justified their cost. 10 to 1 is typical. Every now and then I've seen 100 to 1. One of the best ways to bypass that objective for the first time and build confidence in simulation is indeed make your first model small. A well-chosen first model can typically get highly valuable results within 2 to 4 weeks. And that will typically, if your organization is new to simulation, that's a good way of letting this valuable technology get its foot in the door on your behalf.
Awesome. Um, so what about ergonomics studies? I know that's a little bit different. What kind of software do you use to do that, and how do you implement one of those projects?
The software for ergonomic studies is disjoint from the software for simulation studies. For example, an ergonomic study software, and I'm not one of the experts on that, many of my colleagues are, an ergonomic study might reveal that a certain worker should not be permitted to carry a certain heavy load more than a certain number of times per day to avoid repetitive strain injury.
Hmm.
Therefore, the client, working with us very likely, thinks of a revision to production operation procedures that achieves that objective. The worker doesn't have to carry the heavy load as often. It might be rearranging the shop floor. It might be hiring a second worker as backup. It might be dividing or subdividing the loads so that no one load is as heavy. Well, which of those, or several of them, might be the best idea? We'll try those ideas in a simulation model so that which alternative recommended or suggested by the ergonomics study is the most effective in terms of helping and not overly costing the overall operation. So simulation can be used, should be used, and we have used it to evaluate the various alternatives suggested to achieve ergonomic improvements.
Okay, very good. Hopefully that answered your question. Another question for you, Ed. What simulation models have you done in food manufacturing, and what problems are they trying to solve?
In food manufacturing, excuse me, the typical one is product mix. A very common one is how much of product A should we produce before switching over to product B. When you switch over, particularly in food production, you're likely to have what is often called changeover time. Now, if I'm making vanilla ice cream and the next batch of ice cream I'm going to make is vanilla with chocolate chips, I should certainly do some cleaning of all the vats and containers we're going to use. And that's downtime. It's not value-added time. It's not technically the same as downtime when equipment fails, but it's certainly non-value-added time. On the other hand, if I try a different production schedule where I make strawberry ice cream and then switch to chocolate ice cream, I'd better have a really thorough cleanup that's going to take more time, more non-value added time to do all this changeover. And again, how big are the lot sizes I should make so that we don't accumulate too much of one flavor while the market is screaming for another flavor and we haven't ramped up to produce it yet, and the freezer's getting full, and the financial risk we're taking if the freezer motor fails is increasing beyond acceptable bounds, and so forth. And in food manufacturing, there's often a heavy trade-off between cycle times required, the level of training of your workers. You can shorten those cycle times by having more highly trained workers, but the more highly trained workers cost you more in payroll. And there's also the trade-offs between shorter cycle times and more expensive equipment to achieve them. Will the more expensive equipment earn its keep? A simulation analysis can help decide whether no, we shouldn't buy the more expensive equipment at all, or A, we should buy it right away, or B, we should buy it after wearing out our current equipment so that we amortize its original cost and operational expense. And both of those and various other alternatives are things I've seen when working with food manufacturers.
Awesome. Thank you, Ed. Another question on this ergonomic simulation topic. Do you know which software is most commonly used for ergonomic simulation?
One of the most common ones, a fairly basic one that we provide training in, is called MODAPS. It's a way of assessing by observing workers. Am I moving a finger or the whole hand or the whole arm or rotating my shoulder? And those results can be translated into a collective ergonomic strain that can evaluate the level of fatigue the worker is going to experience. Another more sophisticated one that provides wonderful animations is called Jack, J-A-C-K, like the man's nickname, because the avatar in this splendid automation is often nicknamed Jack, or it can be nicknamed Jane, based on statistics on what's the 50th percentile of height for males versus for females in given populations. Can the worker reach all the shelves in the warehouse without undue straining or having to take time to go up a ladder? And one of the things simulation can do, there are statistical published studies on as worker fatigue increases, the probability that the worker will make a mistake, like an incorrect order pick in the warehouse, will increase. And a simulation software can be used to evaluate exactly how much extra expense, like repicking orders that were picked wrong in the warehouse, is involved if the worker error rate is 2% versus 3% versus 4.5%. So here again is a case I'm prompted to mention where ergonomic results can profitably be fed into a simulation model. And I
Okay.
might mention we have other webinars on the details of ergonomics. They're given by colleagues of mine who are the ergonomics experts.
Thanks, Ed. Also, another software, because I believe Jack is losing support from Siemens, Process Simulate Human is another one that's out there.
Good to mention. Thank you.
No problem. So I'm not seeing any other questions at this time. Again, thank you for attending. We will have a sales representative send you this presentation later today, and feel free to ask them any questions at your leisure. So thank you again, guys. Thank you, Ed. We'll talk to y'all soon. Thank you.
Good day, everyone.
Thank you so much.